Hello children, welcome to channel Sube. Children, today I am going to discuss question number 50 from the MCQ part of 2021 Physics New Syllabus paper. An equilateral triangular conducting loop passes a region of uniform magnetic field of flux density capital B at a uniform velocity v as shown in the figure. The variation of the induced current I in the loop with time t is best represented by so there are 5 graphs given. So let us try to solve this problem. So children, to solve this problem you should know two things. One is, if there is a loop like this, triangular or circular or rectangular, whatever it is, doesn't matter. If it is passing through a magnetic field like this, when it is totally inside, like this, and passing through this magnetic field, totally inside, so you can't take this instant, because one half is out of the magnetic field, one half is inside the magnetic field. So here this instant also you can't take. Totally inside means from here to here. So this region, when the loop is in this region, the current induced is 0. Current induced is 0. I will explain later why it is. So just you have to keep that in your mind. In that region, the current induced is 0. So therefore, we can easily select the center part of the graph should be 0. So this one is correct. This one is wrong. This one is wrong. This one is 0 at the center. So that is correct. This is correct. So only these two are correct. Then we have to choose from these two. Then the other thing you should know is when this loop is entering the magnetic field like this, first it enters this angle conductors, these inclined conductors. So these two in blue color I marked it. So first that inclined conductors enter the magnetic field. Is still the linear, the vertical wire didn't enter the magnetic field, because the limit of the boundary of the magnetic field is this one. So let us mark it like this. This one is the boundary. So this blue color one is now inside the boundary, so that means in the magnetic field. So these blue wires generates therefore current, So the let us mark this using another green color, this one, so that then easy to describe it. So this one like this. So this blue color wires are inside, conductors are inside, so they are generating current, because this one is moving. So moving across the magnetic lines. So then the resultant length or net length, we can say net length, this red side part of the red line inside the triangle, you can see through the triangle. So this red line inside the triangle, this part, the length of this part, length of this line is proportional to the current. That is the net length, the beginning and the end of the wire that is already inside the magnetic field. So from here to here, only this wire is generating current. So the current is proportional to the not that not the length of the wire, but the net length or the resultant length, this length, the beginning and the end. So the line between the beginning and the end, the distance between the beginning and the end of that part of the wire is making current proportional to that length inside the triangle. The red line, you can see the length of that red line is proportional to the current induced. So you see it is little by little increasing linearly. You see inside, only the inside, the red line, the distance, the length of the red line you have to take into account. So that is the amount of current. So the current is increasing linearly like this, and that the direction of that current is towards this way. How do you say that the current is to this way? Because there is a rule called the right hand rule. So you have to use the right hand rule, not the left hand rule. For generators, you have to use the right hand rule like this. So you have to place your fingers, adjust your fingers, the directions of the fingers perpendicular to each other, the thumb and the index finger and the center finger. So this one is the right hand. So I will write it here, right hand. Right hand. So take your right hand and place like this. You have to first direct your index finger to the direction of the magnetic field that is given into the paper, that is given as into the paper. So you have to direct your index finger like this. So you can see the index finger is this one. Index finger is this one the center finger, this one is the thumb. So the index finger you have to direct towards the given magnetic field, to the direction of the given magnetic field like this. So then the thumb you have to direct towards the motion. So the motion towards the right, because they say using this arrow the triangle is moving towards right side like this. So therefore you have to turn your thumb towards that. So when those two fingers are directed properly to those directions, then from your center finger shows the direction of the current. So we are talking about this blue color wires. So the current is to upwards, current is towards upwards, you see. So that is why I drew this arrow towards this side. So the current is towards this side. So only the current generated by this blue color wire. So until this straight wire, green color wire, just before enter the magnetic field, the current is towards left side to this side counterclockwise. That is no problem, it is flowing along this wire and towards the beginning. So the current is to that side. So as soon as so in the graph we can say this one is to the counterclockwise. So still this green color wire is not making any current. So as soon as now it is entered into this magnetic field, what happens? The green color wire also begins to generate current. So what is the direction of that current? So let us use again the right hand, like this, moving this into the paper. So center finger shows the direction of the current. So the direction of the current is upwards like this, same magnitude. So then that happens as soon as the total loop is inside the magnetic field. So now there are two currents each opposite to each other. So there is no net current, therefore resultant is 0. So therefore that is why we said that until this loop is inside the totally inside this magnetic field, the current generated is 0. Therefore the graph is so this one I use this color, and as soon as this one enters, the graph is like this, 0. So then what happens? This one is leaving this magnetic field like this, little by little. So now what happens? The green color wire is generating still current because it is in the magnetic field. The blue color part of this loop is out of the magnetic field, so it is not generating any current. So therefore this one I delete because it has no magnetic field. Then the current is towards right side, this one left side or counterclockwise. Now the current is to clockwise, this one counterclockwise. So the graph must go this way, but the magnitude, let us consider the magnitude. So when it was leaving little by little like this, this blue color current, I have shown the current in blue color, so that current is little by little decreasing, not suddenly, little by little decreasing. So therefore the cancellation is little by little decreasing. So therefore the green color current little by little increasing like this, because the opposite current is little by little decreasing. Therefore the resultant is the green color current. So when the blue half is totally outside the magnetic field, no opposite current to the green color current. So therefore totally the green color current shows in this graph. So that is this point totally. So after that what happens? This green color wire also leaves the magnetic field. So now it has no magnetic flux, so it is outside. So therefore it also vanish. Suddenly, that happens suddenly like this. So the graph is like this then. So graph gets the shape of that. So this one is correct, therefore the fifth one is the correct one for this question. So you have to take into account the direction of the current and the magnitude. The magnitude depends on the net length or the resultant length like this. So children, I think you can understand this. It is not a big issue. So children, let us now do a target question. So children, here is our target question. So try to solve it on your own without my help, honestly. So as you have paused the video, I am not going to make silence video, so therefore I am now going to solve the problem. As I explained, when this loop is inside, total inside like this, from here to here, there will be no current. Therefore the center part of the graph should be 0. So this one correct, this one correct, this one correct, this one wrong, this one wrong. So here this one is a rectangular. So only by this and this wires are making current. These two wires are making current because those are the wires who is moving through this magnetic field, cutting the magnetic lines, cutting. So crosses are magnetic lines, you know, so they are cut by these vertical lines. So therefore those vertical lines only those vertical lines generates current. So these horizontal lines doesn't make any current because they are creeping through these magnetic lines. They don't cut the magnetic lines. To cut the magnetic lines, the motion should be to this way, then they make current. But the way it is passing through this magnetic field, by this red color shown by red color, these wires shown by red color, they don't cut the crosses, they just creep between these crosses. So therefore they don't generate any current. So therefore we don't have to take into account those two wires. So only we have to consider these two wires. So now let us consider, so it is just entering. So when it is entering, the first this right side wire enters the magnetic field at once, not little by little, not gradually as it was in that triangle, but here it suddenly at once enters the field. So therefore it suddenly generates the current. So like this at once, not little by little. The current is not increasing. At once the current is total value. The current is at total value like this. So this one is the correct answer therefore. So as previously, when it was leaving the field, the direction of the current is opposite, because first only this one is in the field. So there we can consider that there is a battery like this, and therefore the current is toward this way. Then when the second one also entered the field, when the second wire also entered the field, that also generate currents towards up. Therefore it has a battery like this. So there are two batteries, each opposite to each other. So therefore no current at this region, at the center. So when this one is leaving, like this, first this part come out of the magnetic field. So now this wire doesn't have any magnetic field, therefore it doesn't make any current. So therefore just only the wire it does. So that this battery is still there. This battery is still there. So it is making current towards other side, right side. So this one is that. This one is that. This one means this part. This part. So when the total wire is outside, so the battery it had also disappeared. So this wire had a battery previously. I had marked it like this. Current pushing this way. So that battery is there until it comes to the boundary like this. The battery is there. As soon as it leaves the boundary, so this battery disappears because it has no magnetic field. Both has no magnetic fields. So therefore suddenly, it happens suddenly, not little by little. This left side wire leaves the field thus suddenly. So therefore the current becomes zero suddenly. So therefore this one is the correct answer. So children, I think you can understand it. So children, I think you are happy. If you are happy, please subscribe my channel, but only if you haven't previously subscribed. If you have previously subscribed, don't touch that button again. If you pressed it again, the subscription will be cancelled. then my numbers will be decreased. Therefore, don't do that. I am helping you, so you can help me like that, and also you can help me by sharing my link among your friends so that I get a bigger audience. So children, you can press the bell icon and you can press the thumb up icon. Then see you tomorrow at 6 o'clock in the evening. Goodbye children.